Good morning, everyone. I'm Narmatha, Assistant Professor, Department of Cybersecurity, working in Dr. S. Lakshmi College of Arts and Science. In today's lecture, we are going to discuss about process states versus process state transitions. So first, we'll see about what is process state and what is process state transition. Process state. The act of assigning a processor to the first process on the ready list is called dispatching. The OS may use an interval timer to allow a process to run for a specific time interval or quantum. Cooperative multitasking lets each process run to the completion. State transition. At this point, there are four possible state transitions. When a process is dispatched, it transition from ready to running. When the quantum expires, it transitions from running to ready. When a process blocks, it transition from running to block. When the event occurs, it transition from block to ready. Ready and running state. The operating system then makes the previously running process ready and makes the first process on the ready list running. These state transitions are indicated as timeout of process name running to ready and dispatch of process name ready to running. So we are assigning ready to running state. Dispatcher. The assignment of the CPU to the first process on the ready list is called dispatching and performed by a system entity called the dispatcher. The choice is often based on which ready process has gone the longest time since it last had a running execution status. But the choice may also involve prioritization of processes. The transition as follows: dispatch process name of ready to running. So we have already seen the diagram pictorial representation of project state. So here green color representation is used to represent ready to running state for a dispatch. Time run out. A timeout is triggered by an external interrupt from a timer device. Information about the process register and PC content is saved into process control block for the process. The process then goes into the ready state when it enters a queue with other ready process. The operating system schedules one of the ready process and dispatch it. Blocked state. If a running process initiates an IO operation before its quantum expires, the running process voluntarily relinquishes the CPU. The process blocks itself pending the completion of the input-output operation. This state transition is blocked process name running to blocked, also known as unblocking. So when the process waits for IO completion or some other event and it completed, the process makes this transition from the blocked state to the ready state. Wake up process name blocked to ready. Suspended ready. When the large number of processes are created and resources are short enough to manage the process, then some of the process will be suspended and moved to suspended ready state. Whenever the resources are sufficient, the process are resumed back to the ready state by midterm scheduler. The process will transition back to ready state whenever the process is again brought onto the main memory. Suspended wait when resources are short enough to manage the process in wait block state. Then some of the process will be suspended and moved to suspended block state. Whenever the resources are sufficient, the process are resumed back to the wait state by MTS. When the process is in suspended ready or suspended wait, it resides in secondary memory or packing store. Using clocks. Clocks are used to maintain the time of delay, indicate quantum expiration, account for resource usage, supporting notification of process at designed times and accumulate performance statistics. Process scheduler. To maximize CPU use, quickly switch process onto CPU time sharing. CPU scheduler selects among available process for next execution of CPU. Maintains scheduling queues of process, job queue, ready queue, device queue. Queuing diagram represents queues, resources, stores. So by process scheduling, we are scheduling different things on process execution. Schedulers. So we have two types of scheduler, short-term scheduler, long-term scheduler. Short-term scheduler or CPU scheduler. So it selects which process should be executed next and allocates CPU. Long-term scheduler, it's like a job scheduler, selects which process should be brought in to the ready queue. Schedulers are described either IO bound process or CPU bound process, spends more time doing IO than computation, any short CPU burst. CPU bound means spends more time doing computation, few very long CPU bursts. Additional of medium term technology scheduling as can be added if degree of multiple programming needs to decrease. Remove process from memory, store on disk, bring back in from disk to continue execution. So by using a swapping concept, we are performing this. So from this, you can understand about what is process state and state transition. And you will also understand the difference between process states and process transition. Thank you.